Evaporation. Evaporation is a process by which water is converted into gaseous state and is returned to the atmosphere as vapor. Water is converted into gaseous state and is returned to the atmosphere as vapor. The factors affecting evaporation losses are: first one is nature of evaporating surface. That is, we know evaporation from a wet soil is faster while evaporation from dry soil is slower. So we can say that evaporation from the surface of wet soil is more faster comparing to that of dry soil. Similarly, black cotton soil help to evaporate the soil water faster than red soil. That is, evaporation in black cotton soil is much more faster comparing to dry soil. Second one is area of water surface. Greater the area, greater is the evaporation loss. That is, we can say the water loss due to evaporation increases with increase in area. Third one is humidity. We can say that evaporation is inversely proportional to humidity. That is, if there is humidity in the atmosphere, then evaporation will be less. That is, if the humidity in the atmosphere is more, we can say evaporation is less. And the fourth one is quality of water. The presence of dissolved salts in water reduces the rate of evaporation. The presence of dissolved salts in water reduces the rate of evaporation. Next is a main topic, measurement of evaporation using Indian Standard Evaporation Pan. Here you can see that the evaporation pan is having a diameter of 1.2 meters. It is having a diameter of 1.2 meters and its depth is about 0.25 meters. So if you please note, all the dimensions given in the figure is in mm, is in millimeters. So we can say it is 1.2 meters diameter and 0.25 meters depth. Here you can see a copper sheet of thickness 0.9 mm and they have hexagonal wire netting all of galvanized iron mesh. Here you can see that this is an evaporation pan. Okay, this is actually the photograph of an evaporation pan and this is the cross section. Okay, all of you know this is a cross section while this is the photograph of evaporation pan. You can refer this also. So as I told you, they consist of hexagonal wire netting, hexagonal wire netting of galvanized iron mesh. Okay, hexagonal wire netting of galvanized iron mesh. It is given in order to protect from birds and also to maintain a uniform temperature both at day and night. You can see that the evaporation pan is having a diameter of 1.2 meter. It is having a depth of 0.25 meters. It is having a copper sheet of thickness 0.9 meters. Then it is provided with galvanized wire netting, hexagonal wire netting of galvanized iron mesh. It's a hexagonal wire netting of galvanized iron mesh in order to protect the water from birds, in order to protect the water which is contained in the evaporation pan from birds, and also to maintain a uniform temperature throughout day and night. That is the purpose of the hexagonal wire netting of galvanized iron mesh. Now we can come to the figure. You can see that the evaporation pan is placed over a wooden platform. You can see the evaporation pan is placed over a wooden platform. and the wooden platform is having a width of 1.2 meters. You can see that the evaporation pan is placed over a wooden platform, and the wooden platform is having a width of 1.2 meters, and it is about 10 centimeter height. In the photograph, you can see that the evaporation pan is placed over a wooden platform, and the height of the wooden platform is 10 centimeter, while the width is 1.2 meters. It is placed over a square wooden platform of 1.2 meter width and 10 centimeter height, so that circulation of air is possible. So that circulation of air is possible all around the pan. It has a wooden platform. You can see here it is 1.2 meter wide and 10 centimeter height, and it also helped to thermally insulate the plant completely from the ground. It also helped to thermally insulate the pan completely from the ground. Then you can see that the water level in the pan is measured using a point gauge arrangement. You can see a fixed point gauge here, and the water level is measured using this fixed point gauge. The water level is measured using this fixed point gauge. Then we can say that measurement is taken at least once a day. At least once a day measurement is taken, and water level is recorded by using this fixed point gauge. Then the evaporation recorded by a pan. Okay, the evaporation recorded by a pan differs from a lake or reservoir. The evaporation recorded by the pan differs from that of lake or reservoir. It may be due to the depth of exposure of pan above the ground. That is, you can see the depth of exposure of pan above the ground. Then some other factors affecting them are color of pan, height of pan, the pan diameter, etc. These factors comes into account. So the pan evaporation will always be different from lake evaporation. Okay, the pan evaporation will be different from that of lake evaporation. We can say it is due to these factors, that is the factors which I have told. So we can say lake evaporation is equal to a pan coefficient into pan evaporation. The lake evaporation is always less than pan evaporation because I told you many factors affect the pan evaporation. So the lake evaporation is less than pan evaporation. And so we can write lake evaporation is equal to a pan coefficient into pan evaporation. Then the pan coefficient of the Indian standard evaporation pan is around 0.8. Around 0.8. Now we can come to, I hope you have understood about Indian standard evaporation pan. Now we can study the new topic, control of evaporation. How can we control evaporation? First one is minimum surface area. So before studying this, you please read what are the factors affecting evaporation. I have explained it. So please read it. So from there you can collect the points. Control of evaporation. First one is minimum surface area. For example, site in deep gorges. Site in deep gorges is always preferable compared to plain areas. Site in deep gorges is preferable to that of plain areas because open space create large evaporation losses. Because when the surface area is large, the evaporation loss will be large. So minimum surface area. Second one is planning an underground reservoir. So it is desirable to plan an underground reservoir because for those reservoir, the interaction with open atmosphere is curtailed. The interaction with open atmosphere is not possible, is not found in underground reservoir. That is, it is curtailed there so that water loss due to evaporation can be very less. It will be negligible so that we can plan an underground reservoir. And the last one is mechanical cover. Mechanical cover, it acts as a barrier between water surface and atmosphere so that we can control evaporation. That is about control of evaporation. Next is design rainfall. A new topic, design rainfall. Design rainfall is a precipitation pattern defined for the use in the design of hydrologic system. It is a precipitation pattern which we depend for the design of a hydrologic system. Then it can be defined by a hydrograph or isohydral map. You have learned about hydrograph and isohydral map in the previous classes. So this can be used for the design of a stormwater runoff system or to find the flow rate of a dam. Then we can know the climatic change. Then we can plan long-term structures like dams, weirs, etc. Then we can know the intensity of rainfall. The probability of intensity of rainfall can be estimated by using design rainfall. So it serves to design the hydrologic system. Then the choice of design rainfall depends on PMP or SPS. PMP is probable maximum precipitation and SPS is standard project storm. First, we can know what is probable maximum precipitation. That is, the choice of design rainfall can be either PMP or SPS. So, we should know what is PMP and what is SPS. PMP is the probable maximum precipitation. It means it is the amount of rainfall over a region which cannot be exceeded over at that place. Which cannot be exceeded over at that place. Okay. PMP means it is the rainfall, amount of rainfall over a region which cannot be exceeded over at that place. That means it is obtained by studying several storms. It is obtained by studying all the storms that have occurred over the region and maximizing them for the most critical atmospheric condition. We are maximizing them for the most critical atmospheric condition. That is, we are studying all the storms and we maximize the value for the most critical condition. That is, we maximize it for the most critical condition, then it is called as PMP, probable maximum precipitation. Next is SPS. You should know the difference. SPS is not maximized for the most critical atmospheric condition, while PMP is maximized for the most atmospheric critical condition. PMP is maximized for the most atmospheric critical condition, but SPS is never maximized for the most critical atmospheric condition. SPS, we can say it is the heaviest rainstorm that has occurred in the region, that has already occurred in the region during the period of rainfall. SPS എന്ന് വെച്ച് കഴിഞ്ഞാൽ അവിടെ ഒക്കർ ചെയ്തൊരു വാല്യൂ ആയിരിക്കും which is the heaviest rainstorm which has occurred in the region during any period, during the period when we study it. Okay, study ചെയ്യാൻ എടുത്തിരിക്കുന്ന പീരീഡ്സിൽ എപ്പോഴെങ്കിലും ഒക്കർ ചെയ്തൊരു സ്റ്റോം ആയിരിക്കും SPS എടുക്കുക. We are choosing the heaviest storm. We are choosing the heaviest storm that has occurred in the region of the basin during the rainfall records. Rainfall records ഏറ്റവും heaviest ആയിട്ടുള്ള storm consider ചെയ്യും when we are dealing with SPS. But when we are dealing with PMP, it is maximized for the most critical atmospheric condition, while SPS is not maximized for the most critical condition. Then for studying the PMP, there are two approaches: meteorological approach and statistical approach. So you should know what's the difference between PMP and SPS. PMP is maximized for the most critical atmospheric condition, while SPS is not done so. So that's the basic difference between PMP and SPS. Okay, thank you.